Hi, everybody. For those of you who don't know me, I'm Becky Carey. I will be walking you all through the PowerPoint part of our remaining 3 labs. This first video for Lab 7 is just a refresher on how to do restriction mapping of plasmids because it's been a few weeks since you last had to do it, and not all of you have your course materials at the moment. If you feel comfortable with your ability to draw restriction maps of plasmids without going back through this video, feel free to skip to the next one. For those of you who would like a quick refresher, we're going to look back over the plasmid mapping exercise we did in Lab 6, just because that's the one most easily available to me. So, when you're looking at a plasmid map, when you're looking at a set of digest results, the first thing you want to do is try to figure out what sizes the various bands are. So I'm going to start by looking at this first EcoR1 lane, because the EcoR1 lane is the easy one, because we know that it has to have a 3 kb band in it, and that band is going to be the vector, always. Then any other band in our EcoR1 lane, we can usually assume is going to be the insert. This particular insert looks like I'm gonna call it 7.5 kb. It's hard to be more precise than that really, but that's just sort of, it's not an unreasonable guess. I would generally go with a number larger than 7, but clearly less than 8 for this band, or 7 or larger, but clearly less than 8 for this band. So 7.5 was what I picked. Then looking at the BAM-H1 lane, that band looks to me to be about 10 kb. So I'll just put that size in here. The next step is that you want to compare the results of the 2 lanes to make sure that the plasmid is the same size, that your size is consistent. So if we look at our EcoR1 lane, we see that this adds to a 10.5 kb plasmid, whereas in our BAM-H1 lane, it's looking like a 10 kb plasmid. So this is the point at which we actually encourage you to fudge your numbers. And I'm going to decide that maybe I got that insert size wrong. Maybe that's not 7.5 kb. Maybe that's actually 7 kb. That number will work much more neatly with our BAM-H1 digest, so we'll go with that instead. So we've got one plasmid with 3 kb vector, 7 kb insert, no BAM-H1 sites in the insert because we've only got one band there. So now we're going to draw our plasmid map. It's a circle. It is a total of 10 kb in size. We ask that you try to keep these roughly proportional. They don't have to be perfect. Don't get out a protractor or anything. But this is a 10 kb plasmid. P blue script is 3 kb. It's going to be about a little less than a third of the total size. So say 3 kb vector for that, and 7 kb insert here. These 2 sites I've labeled here are EcoR1 sites. We'll just label them with an E because that's more convenient. And then all we need to do now is to add the BAM-H1 site, which we know is in the vector and very close to an EcoR1 site. Whether you put it on the left or the right really honestly doesn't matter at this point. It just so long as it is in the vector and very close to an EcoR1 site. Now all that's left is to add our T3 and T7 sites. We know that those are also in the vector, very close to the enzyme recognition sites. The reason that these lines are all different lengths is because I'm new at using this annotate tool, not because they ought to be. So of the 2 primers, we know that the T3 primer binding site is near the BAMH1. We know that the T7 primer binding site is on the other side. And the reason I've put this on the inside of the circle rather than the outside is just that there was more room there. It's not because it needs to be there for some reason. So that would be a complete map of plasmid 1. So now we'll look at plasmid 2. So first thing we notice in this EcoR1 lane is that there's only one band. We know that it's 3 kb. We know that our vector is 3 kb, but we don't know what size this insert is at this point. So we have two possibilities. It could also be 3 kb, or it could be too small to see on this gel. So now we look at the BAMH1 lane to figure out which of those possibilities it is. So right away we see that that BAMH1 cuts this plasmid into 2 pieces, and that the total size of those pieces is much closer to 6 than it is to 3 point some small number. So we know that this 3 kb band is both our vector and our insert. So now, looking at the BAMH1 lane, we pick a size for this band. I think 0.7 kb looks like a good number for it. You might have picked a number that's slightly different. You might say 0.8. That's also perfectly fine. And then we know our total plasmid size is 6 kb. This band is a little above 5. So to get this to add to 6, we'd say, oh, this one must be 5.3 kb. Now we've got the same total plasmid size in both lanes, so now we can draw our map. So again, we start with just the circle. We've got a total size this time of 6 kb, which makes figuring out where to draw those EcoR1 sites pretty straightforward, because it's going to be half vector and half insert. So we've got a 3 kb insert and 3 kb vector. These we know are EcoR1 sites. I like to next do the features that I know have to be in pBluescript. So we'll put a BAMH1 site here, and then our T3 and T7 sites there. So let me move the label on this EcoR1 site up a little bit so that I've got room to label the BAMH1 and T3 sites. So there's our eco site, here's our BAMH1 site, here's T3, here's T7. So that's all the sites in the vector, but we see looking at the BAMH1 lane that we've got 2 fragments there. So we know there must be a BAMH1 site in the insert, and we know it has to be in the insert because we know that BAMH1 cuts the vector exactly 1 time. So there's a 0.7 kb BAMH1 fragment and a 5.3 kb fragment. So there's got to be a BAMH1 site 0.7 kb away from this, and again, we know it has to be in the insert, so we'll put it about there. We'll label it as BAMH1, and then we'll just put sort of a little note here indicating that that piece is 0.7 kb. You don't need to label it separately as insert or a BAMH1 fragment or whatever. It's pretty clear if this is a 3 kb insert that that's what you mean. So that's our map of plasmid 2. Now we go to plasmid 3. Again, start by coming up with sizes for the bands. This looks like 2 kb to me, and we know it's got to be the insert. This has to be 3 kb, and it's our vector. So we're looking at a total plasmid size of 5 kb. So Looking at our BAM-H1 lane, we know it needs to also add to 5. I'm going to call this band 1.6 kb. You could call it 1.5 if you wanted. I wouldn't call it less than 1.5. I wouldn't call it much more than 1.6, but those are both totally okay numbers. So for this, for this to add to 5, we need the other piece to then be 3.4 kb. And that seems reasonable. Again, you could go with 1.5 and 3.5, that would be fine as well, but 1.6 and 3.4 also works. So let's map plasmid 3. Again, first step is the circle, that's the easy part, and the total size. This time, our vector portion is a little more than half the plasmid. So something sort of vaguely like that. We'll label 3 kb vector and 2 kb insert. And these are EcoR1 sites. We've also got our BAM-H1 site, which I'm putting on the left this time just because that's where the cursor was. That's as good a reason as any at this point. It really doesn't matter at this point in plasmid mapping which side you put it on, so long as it's close to an EcoR1 site and in the vector. And now we'll put in our T3 and T7 sites. There's T7 on the side that doesn't have BAM-H1, and T3 on the side that does. Okay, so what we've got now is consistent with our EcoR1 lane, and we've got all the features of the vector. But again, we see there are 2 bands in the BAM-H1 lane, so BAM-H1 must cut this plasmid twice, and the other site, once again, has to be in the insert because we know it only cuts the vector once. So there's got to be a BAM-H1 site 1.6 kb away from this, so that would be sort of over here, which we'll label as BAM-H1, B on that. And then if this is 1.6, that means this is 0.4 kb, making that 1.6, and this 3.4, and that's consistent with what we drew. Again, you could call that 0.5. That's not a problem. Actually, just because I'm finicky, not because you need to be this particular about things, but because I tend to be, I'm just going to move that site down a little bit to make it slightly more proportionate. But there we go. One more plasmid map down. Now we go on to plasmid 4. Plasmid 4, we again see only one band in the EcoR1 lane. So we've got our 3 kb vector, and then we've got either a 3 kb insert or a very small insert. Looking at the BAM-H1 lane, we see that there's only one band and it's only a little more than 3 kb. So we can assume here that our insert must just be small. Too small to see on this gel. So we've got a 3 kb vector, and let's call this, I don't know, 3.3 kb. You could call it 3.2, you could call it 3.4. It clearly can't be 3.5 because a 0.5 kb insert would show up on this gel, but a number smaller than that will work. So we draw the circle. We give it its size, 3.3 kb. We put in our EcoR1 sites. It's going to be here and here, I guess. We label the vector. And the insert, which, let's see. That will work. These are EcoR1 sites. And now we put the BAMH1 site that's in the vector. We put the T3. We put the T7. And we label all of those. Good enough. 3.3 kb plasmid. It's a little tiny insert. No BAMH1 sites in the insert that we can tell. And there we have it. So, plasmid 5, last one, almost done. Again, we've got our 3 kb band. We know that's the vector. And then this time we've got 2 insert bands. And again, what size they are is a little fuzzy. I'm going to call this one 0.8 kb. You don't have to. You could call it 0.7. You might even call it 0.9. It's clearly less than 1. And I definitely wouldn't call it less than 0.7. This one is clearly bigger than 0.5. I'm going to call it 0.6. Because why not? So here we have a plasmid that has 2 pieces of yeast DNA as the insert, not just 1. And we've got a total size of 3 plus 0.8 plus 0.6 is 4.4 kb. That looks like a reasonable size for this BAMH1 band, 4.4 kb. And we make our plasmid map. We do a circle, put its size. The vector part is going to be, I don't know, about 2/3 of the total size. I always put the vector on the bottom. I don't really know why. There's no reason you should have to. You can put it wherever you like. Any rotation or mirror image or whatever of any of these maps is just fine. They're all effectively the same at this point. But we've got our 3 kb vector. We've got, let's see, this is 0.8 and 0.6. I'll put that there. So we've got a 0.8 kb insert. We've got a 0.6 kb insert. How you label this is actually up to you. You could just label this whole thing as a 1.4 kb insert and label the pieces as 0.8 and 0.6. That would be fine. Doing it this way is also fine. This is one of those ways where there are multiple ways to do things. But we've got an EcoR1 site here. We've got an EcoR1 site here. We've got an EcoR1 site here. And based on the BAMH1 lane, we don't have any BAMH1 sites in the insert, which is nice. Now we just put in the BAMH1 site and the primer sites in our plasmid. And possibly your first question would be, but which side should the BAMH1 site go on? And the answer is we don't know yet. Once we get our sequence data, we would be able to tell whether the BAMH1 site was close to the 0.8 kb insert or close to the 0.6 kb insert. But at this point, we have no way of knowing. It could be on either side. Flip a coin. really doesn't matter. I'm going to put it on the 0.8 kb side because that's where my cursor is. So there's our BAMH1 site. There's our T3. And here's our T7. And there we go. We have a map for plasmid 5. And like I said, we can't tell which side the BAMH1 site is on. It is either on one side or the other. Both ways of drawing this can't be technically right, but they're both valid ways of drawing the map. We won't know which one is correct until we get the sequence data. So it might have been that the BAMH1 site is actually over here, but we can't tell yet. I hope this has been an adequate refresher of plasmid mapping. Please feel free to move on to the next part of the videos. And let me stop this recording.